All right, we're on week 12, section 1, Swyk 2, talking about more trigonometric ratios. So, yeah, if you haven't guessed, this is kind of, some of this is kind of review to you. Then we'll move into some newer stuff. But it's all build up for what's happening next week and the week after. I don't know why I have this around my neck. I don't need this right now. So remember, sine, cosine, tangent. That's what we're looking at here. This particular question is a sine question. So starting from angle A, all they're asking me for is the ratio. That's it. They don't want angle A at all. So if you do any inverse sine and then find a degree measure, fantastic, but that's not what they want. They want the fraction, which is the sine. So I always tell my students to identify the opposite side first and the hypotenuse second. And because a lot of kids sometimes are confused about which side is the adjacent side. So if you always do opposite side first, then hypotenuse, and that's all we need in this question, but you can clearly tell the remaining side would be the adjacent side. I didn't even label it, but I can. Anyway, so opposite over adjacent is what we need for the sine, and that's why we use the three letters SOH for so, and then ka, toa, and that kind of stuff. Just a gimmick to try to get you to remember things. But 20 over 29, if it reduces, reduce it. Math Excel does not like it if you don't reduce it. But if it doesn't, hey, leave it alone, move on. Question 9 here, tangent, opposite over adjacent. So the opposite side is here, the hypotenuse is there, that only leaves one side left, which is the adjacent. So 8 over 15, it don't reduce, so don't waste your time trying. Okay, some of them do, some of them don't. Here's a cosine example. Now remember, you got to focus on the angle that they give you. As you can tell, I already screwed this up. You know why I screwed it up? Because the last two examples focused on angle A, and then they switch it up on me and go with angle B. I wasn't paying attention. Look at that. Glad I figured out that. Because angle B, remember, the hypotenuse isn't going to change, but this is the opposite side of angle B. So if you're not paying attention to which angle you're starting from, you get it wrong. The adjacent side is 13, the hypotenuse is 85. So doesn't reduce 13. No, 13 goes into 65, but not 85. Okay, moving on. And 13 is a prime number anyway, which is pretty cool. I know you're not saying it's pretty cool, because you're like, he's a nerd, man. Only nerds think that prime numbers are cool. Although some people have a fear of prime numbers. I know a math teacher who hates them. Okay, so we know how to find sine, cosine, and tangent. Okay, those are, I should write my letters up here. Sine, okay, SOHCAHTOA. But then there are what we call reciprocal trig functions. Sine has a reciprocal trig function called, and when we say reciprocal, okay, I'm going to write the word reciprocal here, we do mean flip it over, right? It's not opposite, it's flip it over. And it's called cosecant, and it's abbreviated CSC. You can search for cosecant and spelling and all that good stuff if you want to, but CSC is its abbreviation. So let's see here. If it's a reciprocal, that means, and it starts with the letter C, it would flip the hypotenuse and the opposite. And then cosine has its own, it's called secant, and you can look up the actual spelling of the word S-E-C-A-N-T, but we abbreviated it SEC. So cosine has its reciprocal starting with an S, and that is a reciprocal, so it's going to flip the adjacent and the hypotenuse. And then tangent has a reciprocal called cotangent. Now, if you don't know that cotangent is the reciprocal of tangent, we're kind of in trouble. But cotangent does start with the letter C, And if it's a reciprocal, it flips the adjacent and the opposite. Now, why did I write all that out? Because SOHCAHTOA has a reciprocal cousin named CHOSHIKAO. That's right, folks, CHOSHIKAO. Now, you don't have to sit there and remember, oh, hypotenuse over opposite, hypotenuse over adjacent, adjacent over opposite. You don't. Here's why. You're just going to take the original function, the original trig function, and flip it over. Now, how did I know which one, when I was in school, how did I know which one went with what? What I realized was that cosine and sine always went with the reciprocal trig function, which started with the opposite letter. That's why, cotangent and tangent, they sound kind of alike. It's kind of hard to mess those up. But secant and cosecant, just remember they start with the opposite letter and you'll be fine. Okay, now, come down here to this question. Question 11 says we find the values of the 6 trig functions. We're going to start with the original 3 for a standard or an angle in standard position determined by the point 5, -12. Now, first thing you do is you find 5, -12. So you can see I drew a diagram, and 5, -12 is in quadrant 4, right? You go right 5 and down 12. Puts you down in quadrant 4. Well, what this is creating is a right triangle. Notice that I always draw my side back to the closest side of the x-axis. This actually is going to create something in the future for trig classes called the reference angle. I would always recommend that you just get into the habit of drawing to the closest side of the x-axis. It'll make your life a whole lot easier in the future. Because otherwise you'll mix things up. Now, that being said, they want the sine. Okay, we'll use color blue. The opposite side of that angle is the -12. The hypotenuse is the 13, so -12/13. Notice what I did. I immediately went down to the cosecant and found that by flipping it over. Remember that reciprocals have the same sign. They don't change sign. I know why a lot of you think that they change sign, because we have drilled it into your brain in geometry class. When you have perpendicular lines, the slopes are opposite reciprocals. That's fantastic for that, but we used the word opposite and reciprocal in that example. This is just reciprocal. Reciprocal just means flip it over. It will stay the same sign. So if the original is positive, the reciprocal is positive. If the original is negative, the reciprocal is negative. You're simply flipping it over, folks. That's it. Okay. Next we have the cosine. Cosine is the adjacent side, which is the 5 over the 13. And then as you can see, I went down and I found the secant right away, flipped it over. No big deal. So tangent, opposite over adjacent. You can see the opposite would be -12. The adjacent is 5, so I wrote -12/5. Came down and found the cotangent, flipped it over. Done. Don't sit there and go, oh, cosecant. That's CHO. That's hypotenuse over opposite, okay? You can do that if you want, but I think it's easier for a lot of you if you just go, cosecant goes with sine. Sine is opposite over hypotenuse. Okay, find that, flip it over, and I'm done. Save yourself a lot of energy. Okay, same thing here. But notice, be careful. Be careful on this one, because you notice that they're changing up the angle. All right, so sine of angle A. Sine of angle A. And you'll notice that the first 3 that deal with angle A, I have labeled in green. I did that because I wanted you to realize that the opposite side of angle A is over there. Hypotenuse isn't changing. That's why the red H and the green H are on the same side. But you'll do know that the red and green opposite and adjacent flip because they switch to the other angle. Okay. So the sine of angle A is opposite over hypotenuse. Okay. That's the 24 over the 74. That does reduce, and you will need to reduce it to 12 over 37. Then you go to secant A. Now, when they want the secant on letter B, look what I did over here on the right. I found the cosine first. Cosine goes with secant. They start with the opposite letter. So the cosine of angle A, that's 70, the adjacent side, over the hypotenuse. 70 over 74, reduced it, 35 over 37. Then I could go find the secant by flipping it over. So always think regular trig function first, and then if I need a reciprocal, I find it. Cotangent A, that's when I went over here and I found tangent A. Sorry, just keep the same color. And tangent A would be opposite over adjacent, 24 over 70. Then I reduced it, right? 12 over 35. Then to find the cotangent, flip, 35 over 12. Let's see if I can move my face and slide this up for the next part. So now we're dealing with the 3 in the red, which are based on the letter B, angle B. Cosecant goes with sine, so I came over here and I found the sine of angle B. That would be opposite over hypotenuse, which is 70 over 74. Hey, that number sounds real familiar. Look at that. Whoa. That's an important principle that it will eventually show up in your life. The cosine of an angle is the sine of its complement. I know that doesn't make a lot of sense to you, but I've seen it show up on the SAT, and it has to do with inside this triangle. When you're at angle A and you're finding the cosine, you can switch to angle B and find the sine, and it's exactly the same. Definitely seen that show up. Once I reduced it to 35 over 37, I wanted to flip it over to find the cosecant, and 37 over 35 is my cosecant. Okay, secant down here of B makes me go back to cosine, so I go back to cosine of angle B, adjacent over hypotenuse, and 24 over 74, and reduce that to 12 over 37, and then get the secant, 37 over 12. Last but not least, wow, this video is longer than I wanted it to be. Holy cow. All right, so tangent of angle B, we've got opposite over adjacent, 70 over 24, which reduces to 35 over 12. And that's not a reciprocal trig function, so I don't have to do any flipping. And that's all she wrote on that one. Okay. Talk to you later. Bye.